Okay, finally, I'm gonna work number 20. I'm gonna find the equation of a tangent line. Now, when looking at the equation of a line, usually they want that in the form of y equals mx plus b. You could give it in other forms, but that's how I want you to give your final thing. So what do we need? Well, we need m. We need a slope, and then once we have the slope and we have some particular x and y coordinate, then we can like solve to get your y-intercept. You can use point slope form if you want. But here's the thing. In number 19, I found the slope. This is the same function as number 19. 2x squared plus 3x minus 8. I found the slope of the curve using the limit definition. I did it in 3 parts, so you can refer to that video. The slope came out to 15. So I'm going to use that slope over here. So here's what I got so far. I've got y equals 15x plus b. I've almost got my entire answer right there, just from the previous part. Now, you might think, oh, well, how do I solve for that y-intercept? Well, here's the thing. We want to know it when x equals 3. This is the slope when x equals 3. Okay? So, well, couldn't I, temporarily, if you want to just use slope-intercept form, you could, if you want to, temporarily plug into x, plug in the 3, and then, oh, we got a problem. I got 2 unknowns. It'd be really nice if I knew the y value, because then I could just kind of like substitute some for y, but not just anything. So if only I knew what the y value was when x equals 3, well, guess what that is? That's just f of 3. If you want to find the y value, apologize for this. This is a duplicate little f of x there. It's a little typo. But anyways, if you want to know the y value when x equals 3, guess what? Plug in 3 into your x's. So instead of 2x squared, it's 3 squared. Okay, instead of 3 times x, it's 3 times 3. Sorry, that should be a plus sign. And then minus 8 is just minus 8, so it's 2 times 9 plus 9 minus 8. Be very careful. Don't do 2 times 3 is 6 and then square it. Order of operations is a common mistake. Anyways, it's 18 plus 9 minus 8. 9 minus 8 is 1. You have to do that first. So 18 plus 1. So 18 plus 1 is 19. Okay. So my y value is 19. So I'm going to plug that in here into my y value. That's just going to be 19. And I'm going to just temporarily substitute these. Then I'm going to solve for b. So 19 equals 15 times 3 is 45. Plus b. Now I want to solve for b. Minus 45. Minus 45. What's 19 minus 45? I'm a math teacher, therefore I'm bad at arithmetic. So let's do 19 minus 45. Thank you, calculator. Negative 26. Lovely. So negative 26 is equal to b. So here's the thing. I've got what b is now. So now I had almost my full answer. Now I've got my full answer. So it's y equals negative 15x minus 26. That's the equation of your line at this point. You might see people do it another way. If you know point slope form, that works just fine. You don't have to worry about this temporary substitution and returning them back. If you know point slope form, which is y minus y1 equals m times x minus x1, you do the same idea. Again, I plug into m, I plug in my slope, which is 15. I plug in y stays as y, but y1 is the y value 45, and then times x minus x1 was x value was your 3. Again, that came from the question. And then you do a bunch of stuff and you actually get the same answer. So you can use that strategy too if you want. Let me show you real quick how you can check your answer if you're worried. So I'm gonna graph this equation, y equals negative 15x minus 26. So I'm gonna go into my y equals. I'm gonna clear out this stuff real quick. And then after I clear that out, I'm gonna plug these equations in. So notice I plugged in the equation of my tangent line. And I'm gonna do my original function too, just to show you I can check your answer. And through movie magic, I did that like super quick. So I'm gonna go to my graph, and you're gonna notice something. Oops, I've got that old window. Let me go zoom standard. That usually fixes things. Zoom standard is option 6. There's alright, here we go, right here. So those are my two functions. Oops, I see an issue. I see an issue. Good thing I did check my answer, because look at this. That should not be negative 15x. What again? I must have solved that negative 26 and thought negative 15 too. It's positive 15x. It's not doing what it should do. And I'll show you what it should do by actually graphing. So checking your answer, not a bad thing. Here we go. Now, if you notice, right, you're gonna notice notice how this thing kind of like starts to hug the curve at some point. Now, what I care about is when x equals 1, 2, like when x equals 3, it's gonna really hug that curve. So what I'm gonna do is I'm gonna zoom out a little bit, okay, and then you're gonna notice, like, you see how it's tangent to the curve at x equals 3, and now I'm gonna get even closer. Second, I'm gonna go to the x value, the x value 3. That's where I care about what my function does, and I'm gonna zoom in on that. You don't have to do all this. I'm just doing some overkill to show you that it's really a tangent line. So notice how at 3, like, oh wow, those things like trace over each other, like they're indistinguishable. So that's how you can check your answer for this. But all it is just use a slope from the previous part, find the y value by plugging it in, plug in your x value, and then, you know, solve for your y-intercept, and that's it. If you have any questions on these, please email me.